Good day, great tribes. Today we are doing the Doppler effect. We are going to start with this question from 2016, from the sub of 2016. That is question number 6, which is out of 10. The reflection of sound wave enables birds to hunt for months. The sound wave produced by the bird has a frequency of 22. That is the sound that is produced by the bird has a frequency of 222 kilohertz and a wavelength of 1,5 times 10 to the power minus 3 meters. Calculate the speed of this sound wave. The first thing that we're going to do is to collect the data. That is 6.1. So we are looking for the speed of sound in air, that is v. Then we are given the frequency, which is 222, but it's kilohertz hour, which means we need to deal with this k. We multiply by 1000, then we get 222,000 hertz or hertz now. Okay, then we're also given the wavelength, that is lambda, which is 1,5 times 10 to the power minus 3 meters. So let's go to the formula and check which formula is correct based on the data. So this is the formula sheet. This topic is under sound, wave sound and light. Okay, so based on our data, we're going to use this formula. Let's go back to the question. So the formula is V is equal to F lambda. Now let's substitute. So V is equal to the frequency, which is 222,000 hertz, times the wavelength is 1,5 times 10 to the power minus 3. Then let's press the calculator. Then we get 333 meters per second. Okay, so that is what the speed of sound in air. Then 6.2 says a stationary bird sends out a sound signal and receives the same signal reflected from a moving moth at a frequency of 230,3 kilohertz. So we are given the frequency that is reflected and that is received, which is, we can say it's FL because it is received. So 230,3 kilohertz. We have that kilohertz, which means we are going to multiply by 1000 in this case. Then we get if we press calculator, we are going to get 230,300 hertz. Okay, so if we multiply by 1000, we're going to get this one, that is 2303. What is it? It's not it's what? It's not 2000. Okay, it's fine. Let's go. Now the question says there, remember 8 cent sound, which is Fs, which was 222,000 watt hertz. Then the bird receives this one. So it can go and plus upper. If let's go to the question, we have 6.2.1. the question is the month moving towards or away. Now if you can look at this one, FL is greater than Fs. So if FL is greater than Fs, therefore we say it is moving towards. So the correct answer is towards the bed, because F received is equal to F emitted. So FL or is greater than FS. Okay, now let's go to this question 6.2.2. Calculate the magnitude of the velocity of the moth, assuming that the velocity is constant. Okay, so we are on 6.2.2 now. So we are going to use that formula. Let's go to the formula sheet. Now that there is a change in frequency, we are going to use this formula of the Doppler effect, because there is a change in frequency. Okay, which says FL is equal to V plus or minus VL divided by V plus or minus Vs times Fs. Okay, let's go back. It's FL, which is equal to V plus or minus VL divided by V plus or minus Vs times Fs. So we are going to use this formula, knowing that this one is the sound received. This is the frequency received by the listener. Then this one is the velocity of sound in what? In air. Ebesibalile up there. Then this one is the velocity of the listener, velocity of the speed of the listener. It's the speed of the what? Of the listener. Okay, then this one is let's look at this one. This one is so it's a sound received. This one, sound received. Oh, the sound emitted. So sound emitted. So then this one is the speed of the sound source, speed of sound source. So this one is the sound, is the speed of sound in air. Okay, so this one is the frequency received, is the frequency received or heard by the listener. Okay, so what is happening here? We said the sound source is moving towards the bird, which is a listener, which means we are going to say, okay, let me just write it here. The sound source is moving towards a stationary listener, which is a bird in this case. Okay, so let's work out the formula. What you do here, you have to choose one sign here and one sign here. Okay, now indlela endenza ngayo ndizayibhala kanje, that is FL divided by Vs times Fs. Okay, so it's not moving in our case, stationary listener. This one is 0, which means we are left with this one and these two plus that one. Okay, so they say the sound source is moving towards a stationary listener, meaning that the sound source is moving towards, meaning that the listener is not happy because it's coming with a noise, right? Which means we are going to put a negative sign, because moving towards a listener is negative. So we're going to put a negative sign here. We can just put plus, but there is no problem, which means we have the formula now, which is V ngezantsi we V minus Vs times what? Fs. Hoping that is clear. Now, if the sound source is moving away, the listener is happy, which means we are going to write positive here. If the sound source is moving towards, the listener is not happy. Okay? But if it's the listener that is moving towards, we put positive with listener. Okay? So let's substitute. We have the frequency heard by the listener, which is 330,3 kilohertz. Then I convert to this value. Let's substitute. So we have 310, it's 230. Then we have here 300, which is equal to this. The velocity of sound in air was 333 divided by 333 minus Vs times 222,000. Now, what I do, I always divide by Fs both sides. So I will divide by this value both sides. Now I will do the same, that is 222,000. So that cancels that. Now we are left with, let me press calculator here. So the answer here is 1,037, which is equal to 333 over 333 minus Vs. Then I cross multiply. I have 1 here, then I cross multiply. 1 times 333, so the answer is 333. Okay, which is equal to 1,037 times 333. Then let's press calculator here. So the answer here is 345,45, right? Then 1,037 times negative, yes, it will be negative 1,037 Vs, right? Then sorry for that. Now let's continue. Let's go back to the question. Where is it? Oh, we are here. Now we transpose this one to this side, right? Then we get the answer, which is so we get negative 12,45, which is equal to negative 1,037 Vs. Then we divide by negative 1,037 and 1,037. Then the answer, that is the velocity of sound source, will be equal to, then we divide by 1,037. Then the answer is 12 meters per second. Then we're done. We're done with this question. Let's go to another question. Same question. That is the Doppler effect again. So question number 6. They say here the whistle of a train emits a sound frequency of 2,000 Hertz. A stationary listener measures a frequency of 2008. The speed of sound in air is this one, which means we have a data. There we have the frequency that is emitted by the sound source, which is 2,000 Hertz. Then we are given the frequency that is measured, which is 2080 Hertz, right? Then we are given V, the sound the velocity of sound in air, that is the speed of sound in air, which is 340 meters per watt per second. The first question, that is 6.1, says name the phenomenon responsible for the observed change in frequency. That is the Doppler effect. Doppler effect, right? Then let's go to 6.2. Is the train moving away or towards the stationary listener? So if we can look here, FL is greater than Fs, therefore it is moving towards FL. This is FL, which is greater than this one, therefore it's moving towards. Then 6.3, calculate the speed of sound in air. The first thing that you do, that is 6.3, let me write it here. 6.3, you first write the formula as it is, that is V plus or minus VL divided by V plus or minus Vs from the formula sheet. Then the second thing that you do is to choose the signs here. Now the what is moving here? What is moving? The listener is stationary. So when the listener is stationary, VL is equal to 0. Okay, then we say the sound source is moving towards. The sound source is moving towards. Sorry, the sound source is moving towards. So we have VL divided by VS times what? Fs. We want to choose the sign. So this one is equal to 0. So this one is moving towards. It is irritating the listener. We put a negative here, which means here is positive, right? Now let's substitute. FL is 2080, so we have 2080. So V is 340, so we have 340 plus 0. No, there is no change. So we have 340 minus Vs times Fs, or Fs is 2000. Then I said, on the first question, we first divide by this one. Always when we are looking for this one, divide by this one. So let's press calculator here. So the answer here is 1,04, which is equal to the side is 340 divided by 340 minus Vs. Now step number 2, you cross multiply. So we have 1 here, we cross multiply 1 times 340, here 1 340, which is equal to, then we multiply this by this one. Then we get 353,6. Then this one times this one, it's minus 1,04 Vs. Then we transpose this one. So when we transpose it, the sign changes to a negative. So we have 13,6, which is equal to, which is negative 1,04 Vs. Then we divide by minus 1,04, both sides minus 1,04. So Vs is equal to 13,08 meters per second. Now let's look at another question, this one. Will the frequency observed by the observer sitting in the train be greater than, equal to, or smaller than 2000 Hertz? So there is no relative velocity there. The velocity of a listener is the same as the velocity of the sound source. Therefore, the answer there will be equal to, because i-train ihamba ne-listener, so they have equal velocity there. So there is no change in frequency in that case because of the equal velocities. So the answer is equal to. Now let's go to another question of the Doppler effect. This is the Doppler effect, and you are given the graph. A learner investigates the relationship between the ratio of the observed frequency to the sound frequency and the velocity with the listener moves relative to a stationary sound source. The experiment is repeated by increasing the magnitude of constant velocity with the observer moves relative to the change or to the same stationary source. Okay, the observed frequency, that is FL, is recorded and the ratio is calculated for each experiment. The graph below shows the results obtained. Now let's look at the graph and analyze the graph. Now, if you can look here, we have the x-axis. Remember, we have v coordinates to x, y. Okay, so when we have v coordinates, meaning that we have v what VL versus the ratio, la ratio yethu sinikwe pha. Okay, these are the coordinates in this case. Now, sithi xa sithetha siqala ngo-x always because we say xy. As the velocity of the listener increases, the ratio of this increases also. As you can see, everything is increasing. So as this one increases, this one increases also. So this one is our independent variable. So this one is the the ratio is the dependent variable, right? So let's continue. Let's go to the question. They say state the phenomenon. State the phenomenon. This is the Doppler effect because there is a change in frequency observed by the listener, because the listener and the sound source has different velocity relative to the sound propagation. Okay, this one is a Doppler effect. When they say state, you mention and state it. Okay, so this is the Doppler effect. Then you define the Doppler effect as the change in frequency observed by the listener, because the sound source and the listener have different velocities relative to the medium of the sound propagation. Now, use the graph to answer the questions. Is the listener moving towards or away the stationary sound source? Now, since the frequency, remember we have FL and and FS, and this one is constant. This one is constant. The sound emitted by the sound source is always constant. So this one is changing, and in this case is increasing because the ratio is increasing. So this one is increasing while this one is constant. So if the sound received by the listener, or if FL is increasing, when FL is increasing, FL is increasing. When FL is increasing, therefore that is towards. Therefore it is moving towards. The train is moving towards. The train is moving towards. That is 6.2. towards, because the frequency received by the listener is increasing. So we are going to explain like this, okay? Since it is moving towards, the wave fronts, bullet number 1, wave fronts are compressed. When the wave fronts are compressed, the wavelength, that is the lambda, becomes shorter. So becomes shorter. The frequency becomes higher. So we say it is moving towards. The frequency is increasing, become higher. Reason, the wave fronts are compressed, the wavelength becomes shorter, the frequency become higher. Okay, now let's go to this question. This question says, what does the gradient of the graph represent? What does the gradient of the graph represent? Let's go to the formula of the Doppler effect formula and see what is happening there. Remember, here we have the ratio, but here we have meters per second. Okay, now let's go to the formula and see what will happen. When we calculate the gradient, we say the gradient is equal to change in y over change in x. So in this case, on the y-axis there is just a ratio. Let me just say 1 divided by, on the x-axis there is v. Okay, that is 1 over v. Right, so let's go to the formula. No, this one is correct, so there is no need to go to the formula. We have 1 over v, that is the answer. 1 over v, which is the inverse of the speed. Inverse of the speed. Inverse of the speed of what? Of a listener. Right, so this is what we're looking for. On the y-axis there is a ratio. We can just say 1. The ratio is any number, so that is the ratio. We can just say 1. Then on the x-axis we have VL, so I'll just put VL. So this is the answer, or you just say inverse of the speed of the listener. Now let's go to this question number 6.4. Calculate the speed of sound in air. That is 6.4. So 6.4 is FL is V plus or minus VL divided by V plus or minus VS times FS. So we always divide by FS. This cancels that, so we have the ratio that was written on the graph. Then if we can look here, we can take any point. This point will give us these coordinates, that is 1, 1, 2, 4, 6, 8. So 1, 1, 2, 3, 4. So this is 1, 3, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So this is 1, what? 3. You can use, or 1,03 I mean. So the coordinates is 10 is to 1,03. Right? Okay. 10 is to 1,0. 10 is to 1,03. Then this one is equal to FL divided by FS. So with that 10 is to that. Now we can substitute. This one is VL. What is happening now? Which sign we are going to use? They said, is the learner moving towards or away? Is the learner moving towards? We said towards. So the listener is moving towards. The listener is moving towards. That is the listener, which is the learner. Meaning that this one is not moving with 0 layer. Then we have FL over FS, which is equal to, this one is what we're looking for. When the listener is moving towards, is willing to go there, so we say plus, then divided by V, because this one is 0. Right? Now we can substitute. We do have this one. Okay, we do have all of this. Okay, so the ratio there is 1,03, which is equal to, this one is what we're looking for, plus this one is 10 in our case. So this one we're looking for, then we cross multiply. So when we cross multiply, we have this and this one, 1,03 V is equal to 1 times V is V, 1 times 10 is 10. Then we transpose this one. So we are left with 0,03 V, which is equal to 10. Then we divide by 10 or by 0,03, 0,03 both sides. Then V is equal to 333,33. Then meters per watt per second. Then the question is answered. This question is answered. Now let's go to this question. An observation of a spectrum of a distant star shows that it is moving away. It is moving away from Earth. Explain in terms of frequency of spectral light and how it is possible to conclude that the star is moving away from Earth. So in this question, since they talk about away, which means here we are talking about the red shifted spectral lines, red shift. So when the spectral line is shifted towards a red, we say it is shifted towards a longer wavelength. Longer wavelength. Okay, so if it is a longer wavelength, which means the frequency there is lower. Frequency is lower. That is what we're talking about. Therefore the star is moving away. So this is the explanation that you can give. So there it's the red shift, meaning that the spectral lines are shifted towards a longer wavelength and a lower frequency. Let's go to another question. This is the last question that I have now. So we are going to do this question now. This is my last question. Okay. An ambulance with a siren on moving at a constant velocity towards a person standing next to the road. The person measures a frequency which is 1/10% of the frequency of sound sourced by a siren sound emitted by what? By the siren of the ambulance. Name the phenomenon. This is the Doppler effect. The Doppler effect is the change in frequency heard by the listener, because the listener and the sound source has different velocity relative to the medium of the sound propagation. And now, if the speed of sound in air is 340, calculate the speed of the ambulance. Okay, now what is happening here is that the sound source, let me start with, is moving at a constant velocity. The person standing, okay, so the velocity of the listener is equal to 0, okay. Then the sound source, that is Fs, we don't know it, but it is moving towards. Okay, it's fine. So let's say this one is X. Let's say it is X. Towards a person standing next to the road, the person measures a frequency which is 1/10%, which means we are going to calculate the 1/10%, that is FL will be 1/10% of this. 1/10% we always divide by 100 to the percent. 1/10% of the sound emitted of X in this case. Then the question says calculate the speed of the ambulance. Calculate Vs. So it is very simple. We're going to write the question. The formula as it is 6.2, which is FL is equal to V. Sorry for that. Let me correct it. Okay, which is equal to, what is this? Which is equal to V plus or minus VL divided by V plus or minus Vs times Fs. Now, let me write it here. So we have Vfs, which is VL divided by Vs times Fs. Now, what do they say? They say the sound source is moving towards, which means here we put minus. Therefore, here is plus, and this one is also equal to 0. Now, let's substitute. Fs is X, FL is 1/10X. So we have, sorry for that. Let's go. All right. So this one is X. This one is 1/10% of X, which is equal to, this one is 340 divided by 340 minus Vs times, this one is X in our case. We say this must be X. Then this one is 10% of this one. Okay, then we always divide by this one both sides. So X is out. Now we are left with 1/10%, which is 1,1. 340 divided by 340 minus Vs. Then what do? We cross multiply. So 1 times 340 is 340 minus, and press the calculator there. 340, so it's 3. This time this one is worth 374. Then this one times this one is minus 1,1 Vs. Then we transpose this one. Then we change sign. So we get 34. which is negative 1,1 Vs. Therefore, we divide by negative 1,1 both sides. Then Vs is equal to 30,91 meters per second. Then we're done. That is how we answer this question. That is the Doppler effect. Thank you. Please subscribe to the channel. And please follow me on Facebook. That is Lukhona M Sciences for more questions. Thank you. Bye.